Good morning, Year 10. Mr. Davidson here, and I'm going to talk you through the work you need to do on rivers for your 5th week of work on rivers, specifically looking at how we prevent or reduce the impacts of flooding. So just a very quick notice, if you're in school this week, that's Monday the 6th of July to Friday the 10th of July, you do not need to do this work because you'll be doing separate work in school with your teachers this week. If you were in school last week, you need to complete the work from last week, and that is all on Teams as week 4, what causes rivers to flood. If you are not in school this week and you were not in school last week, you need to do this work. Okay, with that out of the way, let's talk through it. So at this point in the rivers unit, you are fluvial experts, and fluvial means river. If you ever hear a question about fluvial processes or fluvial features, that means river processes or river features. You know about these processes, about transportation, erosion and deposition. You know about the features they create, and you know about the risk of floods and how different factors, be that deforestation or urbanization or the shape of the land, steep slopes or shallow slopes, how these factors can affect the risks of flooding. What we're going to do today is look at how we can manage those impacts. How can we reduce the risk of flooding? And you will notice that we're going to talk about hard engineering and soft engineering. We've already done this in coasts when we looked at coastal protection. We're now going to look at hard engineering and soft engineering in terms of rivers, how we can change the river, how we can change the land around the river to reduce the risk of a flood happening. So here's what I would like you to do this week, and you're going to need pages 126 to 129 in the textbook, as it's all fairly self-contained, which is great. So once you've got your textbook open on your screen, or if you've got a copy of it at home, that's great. You need to do the following. The first thing you need to do is to recap the definitions and key differences between hard and soft engineering. Now, this is another pitfall that a lot of students fall into when they're comparing rivers and coasts. They get mixed up about which unit they're talking about. So remember, if you're talking about rivers, you're talking about upper course, middle course, lower course flooding. If you're talking about coasts, you're talking about landforms created by erosion and deposition. You're talking about storms damaging the coastline. And hard and soft engineering is probably the most confusing bit because we use the exact same terms in rivers and coasts. So what I would like you to do first is to summarize hard and soft engineering, and there's some bits in the book, but make your descriptions specific to rivers. Because if you start talking about coastlines or seawalls, for example, or groins, you're in the wrong unit and you're not going to get any marks for that. So make sure you're making your definitions specific to rivers so that you can remember the difference. Once you've done that, I would like you to do 3 things. And it's fairly straightforward this week. I think you should be able to get through it quite quickly. The first thing I want you to do is to copy the diagram from page 126. So that's this diagram here. And I would like you to copy that into the middle of a page. You could either cut it out, like you could copy and paste it, or you could draw it and then take a picture of it. The key thing though, do not add any of these annotations. I only want you to copy the picture itself. Do not add annotations because we're going to be adding our own that are far more informative than the short ones in the book. Once you've copied the diagram, you then need to add a series of detailed annotations that explain different examples of hard and soft engineering that can be used to help reduce flood risk in a river, not the coast. So section 3 in your task this week, these are all hard engineering methods, and task 4 is soft engineering methods. So you need to work through these prompts, you need to summarize the information from the textbook onto your own annotated diagram. So let's do one together just as an example. So you need to draw your diagram, and the first type of hard engineering you need to annotate is channel straightening. So how does it work, and are there any disadvantages? So let's make this a bit bigger first of all. So hopefully you'll have this diagram right here, and you will have read through the river straightening, channel straightening section here. So I'm going to find the relevant bit of this diagram, and it looks like this section has been straightened here, and I'm going to add a description of what it is So essentially, channel straightening is turning a bendy river into a straight one. And obviously you're going to give it slightly more detail than that, but that's the underlying fact. And then you need to explain, how does this reduce flood risk? How does making a river straight rather than bendy reduce the chance of a flood happening? And you might want to think about the speed of water, because remember, a flood only happens if a river cannot carry water fast enough. If there's more water going into the river than the river can transport away, then the river's going to overflow. So surely then, if the river's moving faster, it can carry more water and it can flood less, hopefully. And that's what channel straightening aims to do. So I'll be adding these annotations to this section of my diagram. But also you need to think about disadvantages. Always we're thinking about benefits and drawbacks. And there are some drawbacks to channel straightening. First of all, if you're putting loads of concrete around a river, it doesn't look very attractive. It stands out. That's why it's hard engineering. It doesn't look particularly good. It might affect tourism or the natural environment. Also, you could argue that sometimes these channels can get lots of sediment building up. Even though channel straightening speeds up the water, which means there'll be less deposition, there will still be some. And over time that can build up and reduce the effects. So that's an example of the annotations I would be looking for around this diagram. Because remember, you're going to need to use this information in an exam question, and almost certainly an exam question will be testing you on, what does this person know about different types of engineering to reduce flood risk, and what does this person know, what judgments can they make about the benefits and drawbacks, which ones are the best, which ones are the worst, and why does this student believe that. So you need to do that same process for 3 types of hard engineering: channel straightening, embankments, and dams and reservoirs. And then you need to do another 3 for floodplain zoning, wetlands, and flood preparation. So hard engineering is on page 126 and 127, and soft engineering is on page 128 and 129. By the end of this week, you should be able to summarize really clearly examples of hard and soft engineering. You should be able to explain their benefits and their potential drawbacks, and you should be able to come to a judgment. If you were asked to use one of these, which do you think would be most effective and why? Once you've finished annotating your diagrams, the only thing left to do will be to complete the weekly quiz, which I'll post to Teams on Wednesday. If you have any questions at all, email your teacher, let me know, ask us in Teams, and we're looking forward to reading through your quiz results at the end of the week. Have a great week, Year 10.